In this reaction, we will cover the specific conditions of the addition of cyanide to carbonyl compounds. Now for the same reaction of cyanide addition to form the cyanohydrin, there are actually three different sets of conditions and reagents that we can choose from. Firstly, we can use HCN with trace amounts of aqueous KOH. Hydrogen cyanide by itself is a weak acid and ionizes in water only partially to generate some amounts of our actual nucleophile cyanide ions. However, adding a base such as potassium hydroxide will consume the H+ ions, and by Le Chatelier's principle, as you have learned in chemical equilibria, this will push the reaction further to the right and generate more cyanide ions to attack the carbonyl as shown in the equation here. Now the next method involves the use of HCN again, but this time with trace amounts of KCN, which is potassium cyanide salt. The idea here is slightly different. At the start of the reaction, the cyanide that actually attacks the carbonyl comes from the KCN salt. Now we know that at the end of the nucleophilic reaction, we have to protonate the negative oxygen atom. Hydrogen cyanide is actually therefore used as a protonating acid, and of course this will generate even more cyanide ions to continue the reaction. This is somewhat like a chain reaction. The mechanism here will make it much clearer. The last method involves the usage of KCN and H2SO4. In this case, H2SO4 or sulfuric acid is the protonating acid, and most chemists use this method because hydrogen cyanide itself is a very toxic gas. However, in this case, we cannot use trace amounts of KCN anymore. We have to use stoichiometric quantities of KCN since it's our only source of cyanide ions. Notice that for all these three different methods, you need to draw the mechanism slightly differently depending on which set of reagents you use. Of course, do be mindful of the protonating acid when drawing the mechanism.